All right. We are going to do some reviewing of complex numbers to get you ready for the complex numbers quiz. All right, so in the starter, we are simplifying a couple of radicals. In class, I asked which one was easier, the first one or the second one, and the consensus seemed to be that the second one is easier. I need to enable my pen here. Second one is easier, this one, because 25 is a perfect square. Now remember, the first thing we need to do when we're simplifying the square root of a negative, the very first thing is we bring the negative out as an I, because the square root of a negative number is not real, it's imaginary. So we use I for imaginary, take I times the square root of 25, and then we simplify the square root of 25. Remember, 25 is a perfect square. It's 5 times 5. So the square root of 25 is 5, so we have I times 5, but we don't write I5, we write 5I, and we're done. So that one's super simple. Number 1, we're going to bring the negative out as an I. This one's going to be more complicated because 24 is not a perfect square. So we're going to take that 24 and we're going to break it down as 2 and 12, 2 and 6, 2 times 3. So 24 is 2 times 12, 12 is 2 times 6, 6 is 2 times 3. I'm going to circle up all of my prime factors, and I'm going to pair up my primes. So I have a 2 squared. That takes care of those two right there. I have another 2, and I have a 3. So square root of 2 squared is 2, and the 2 times 3 is going to multiply back together as a 6. That's this 2 and 3 right there. And we have our answer. Not too bad. Okay, we're going to do a couple more examples, actually 4 more. So moving to the next page. Simplify each complex number, write your answer in standard form. We need to remember that standard form is a plus bi. And if a is 0, we just write bi. We don't put an extra 0 in. And if b is 0, it's a real number. Okay, so this one, example 1, square root of negative 343. First thing, negative under the radical means we have an imaginary number. So I times the square root of 343, and then we're going to simplify that radical. All right, 343. It is not even, so I can't divide it by 2. I will try a 3. 343 divided by 3 is 114.33333, so it's not divisible by 3. I'm not going to try a 5 because it doesn't end in 0 or 5. Next prime to try is a 7. So 343 divided by 7. That one works. 343 is 7 times 49. 49 is 7 times 7. We have our primes. We're going to pair them up. Pair primes. Yeah, pair them up. I don't know why I crossed through those. I guess because that pair is coming out as a 7. Kind of like what our notes talked about. So we have 7i times the square root of 7. And we're done. Number 2. Example 2. First thing I want you to notice, this is negative 5 times the square root of negative 200. So anything that comes out from under that radical is going to multiply with our negative 5 because it's negative 5 times the square root of negative 200. So first thing we're going to do, we're going to bring the negative out as an I because the square root of a negative number is imaginary. So I have negative 5 times I times the square root of 200. And we're going to take that 200. We're going to break it down. 2 is a prime. That branch isn't going any further. 100 is 2 times 50. 2 is a prime. 50 is 2 times 25. And 25 is 5 times 5. We've got negative 5i times the square root of, we'll write that 200 as, so there's a pair of 2's right there. We have an extra 2 that is not part of a pair. And then we have a 5 squared. So 3 2's, 2 5's. Okay. Perfect squares come out, so the square root undoes the square. So that 4 right there comes out as a 2. 2 squared is a 4. So negative 5i, we're going to multiply it with a 2 that's coming out. There's a square root of 25, which is 5. That's coming out. And under the radical, we leave this little 2 right there. Okay. There we go. So we have negative 5i times 10. Switch them around a little bit. That's times 10. 2 times 5 is 10. Switch the order that we multiply. Negative 5 times 10 times I. That's negative 50i times the square root of 2. And we are done. That's example 2. All right, a couple more. And notice for each of these, they're pure imaginary numbers. This one's 0 plus 7i, square root of 7, right? We don't usually write it that way. Pure imaginary numbers. Okay, example 3. We've got a complex number here. We got a complex number here. We got a complex number here. And notice in between the parentheses, we have a plus sign here, a subtraction sign here. So we're adding and subtracting. We are not multiplying. So remember, the idea is treat the I like a variable. It's not a variable. It's a number. It's the square root of negative 1. But we treat the I like a variable. And in the next problem, we'll see an extra twist with the I, but we're going to treat the I like a variable. So treat it like an X. We're going to remove the parentheses and combine like terms. So we're adding a negative 3, which is subtracting a 3. So that right there. We're adding a 4i. And back here, we have to distribute the negative. We're subtracting a negative 8, and we're subtracting everything that's inside those parentheses. We're subtracting a negative 8, which becomes adding 8. Right? Or just think of it as distributing the negative. That's the way we learn it in 7th grade, 8th grade. Negative and negative make positive, and here negative, we subtract a 2i. That sign also has to change. Okay, now we're going to combine like terms. Which ones are alike? The 2, the negative 3, and the 8. And then the negative 7i, the plus 4i, and the negative 2i. All right, these guys right here. 2 minus 3 plus 8. That's negative 1 plus 8, which is 7. Or we can do 2 plus 8 is 10. Take away 3 is 7. Either way. These three guys right here. Negative 7i plus 4i is negative 3i. And then take away 2i. We get negative 5i. So do negative 7 plus 4, and then take away 2. We get negative 5. There's an I with that. So 7 minus 5i. And we're done. But look at the operations. We're adding, we're subtracting. Okay. Example number 4. Negative 5 plus 4i inside parentheses and 9 plus 12i inside parentheses. We're multiplying. We need to understand that when these parentheses are right next to each other, that's multiplication. So we're multiplying. So this time we are going to multiply. Should I write that somewhere? Yeah, you can write it down. We're multiplying. So we can either use the distributive property. Let me show you how that works. The negative 5 gets to multiply with each of these. Okay, negative 5 times 9. Let's do that one first. Negative 5 times 9 is negative 45. And negative 5 times 12i. Negative 5 times 12 is negative 60. That's negative 60i. And then we're going to do, let me switch colors here for a sec. 4i times 9. And 4i times 12i. 4 times 12 is 48. I times I is I squared. Don't lose the I squared. Okay. Then we're going to remember that I squared equals -1. So we have -45 minus 60i plus 36i. I should just put those together. 48 times -1 is going to be -48. So I have -45 and -48. This is a -48 right here. And then the -60 and the positive 36i, the -60i and the positive 36i are going to be -24i. -45 minus 48 is -93. And we have our answer here. Now, we're done, but I'm going to show you the box method because it seems like my students really like the box method. So I'm going to do -5 plus 4i times 9 plus 12i a different way. It's actually just using the distributive property, organizing your information in a table. So let's follow it through. So we're going to do, as we create the table, the box. So the box method, -4 plus 4, or sorry, -5 plus 4i. If you want to put a positive in front of that, you can. Doesn't need to be. And then 9 plus 12i. Again, if you want to put a plus sign in front, you're welcome to. Okay, now we do the multiplication. -5 gets to multiply with the 9. -5 gets to multiply with the 12i. Notice that's what we did over here as well. Okay. Then the 9 gets to multiply with the 4i. And in this last one, 12i times 4i. So 12 times 4 is 48. I times I is I squared. And now this box method of multiplying, we add up the 4 things that are in the box. So we have -45. And then we'll have 48i squared, which is going to be 48 times -1, which is -48. So we'll put those two together. We have the 36i and the -60i that are going to add up. So we get the same thing, -93 minus, oops, I lost a 0. -93 minus 24i. And we get exactly the same answer. Just a little different way of organizing the distribution. And that is our review for the complex numbers quiz.